Welcome to Cosmic Compass, the channel where we journey through space, uncovering the hidden stories of our solar system and beyond. Tonight, let's turn our eyes to a world we think we know so well, the moon. Familiar, constant, but filled with mysteries, waiting to be revealed. We may take the moon for granted. It has always been there, in our night sky, bright and familiar. But how often do we really stop to think about what we're looking at with the naked eye? We can already see dark plains, bright highlands and craters that tell of violent impacts. Through a telescope, the view becomes even more detailed and dramatic. But what we're about to explore together goes far beyond what even a telescope can offer. Since 2009, a spacecraft has been orbiting the moon, scanning its surface with a powerful camera, the Lunar Reconnaissance Orbiter, or LRO. Over the years, it has captured stunning images that reveal strange formations, hidden processes, and even clues about the moon's potential future role in human exploration. So let's dive into some of the most intriguing and puzzling discoveries the LRO has shown us. Our first stop is a curious little crater that at first glance seems ordinary. But look closer inside, it is smaller craters, and the entire feature itself is embedded within two neatly aligned rings. It almost looks like a cosmic bullseye stamped into the moon. This type of formation is known as a concentric crater, sometimes nicknamed a donut crater. You might think this happened simply by chance, with two impactors striking the same place at different times, but the story doesn't add up so neatly. If random double impacts were responsible, we should see concentric craters scattered randomly across the moon. Instead, they cluster in particular regions, especially around the Oceanus Procellarum, a vast lunar plain. Even more intriguing, many of them seem to be of similar age, and their outer rings are unusually shallow compared to typical craters of the same size. So what could explain this? One theory suggests that these craters formed when the lunar surface was neither fully solid nor fully molten, something like cooled lava or thick honey. An impact in such conditions could create ripples that froze in place before they could smooth out. But most scientists lean toward another explanation, that these craters were later deformed from beneath, pushed upward by magma during a more geologically active period of the moon's history. This theory would explain both their shallowness and their unusual clustering. Still, no theory has solved the puzzle entirely. What do you think? Could these be the frozen echoes of an active moon, or evidence of impacts stranger than we expect? We often imagine the moon as a place where nothing ever changes, a silent world frozen in time. But the LRO has shown us that while rare, the moon's surface can and does shift. Take Kepler Crater, about 32 kilometers wide. Along its inner walls, the orbiter captured dark streaks that betray a history of landslides. As we zoom in, we can see that the material tumbled from box canyons near the crater's rim, cascading down to the floor below. What's striking is how fine this material appears. The flow looks smooth, with no large boulders resolved. Yet at the bottom, the biggest dislodged rocks did collect, revealing the scale of what was set in motion. Even more fascinating, the landslides don't look like one giant collapse. Instead, they are made up of many smaller slides over time. What set them off? The most likely culprits are tiny meteors. Each small impact acts like a trigger, loosening material until it slides downhill. Over countless centuries, these miniature avalanches soften, and round the edges is craters. That's why older craters appear smoother and less rugged than fresh ones. So while the moon is quiet, it is not truly still. Even in its silence, it slowly reshapes itself. Next, let's turn to one of the moon's most remarkable features, Messier Crater. Unlike most craters, which are roughly circular, Messier is long and narrow, like a gash across the lunar surface. At first, this seems like a mistake of perspective, but zooming out, we notice something even stranger. Beside Messier are two additional craters, lined up in a row. The one on the left looks older and eroded, the one on the right fresher and sharper, did a new impact overlap an older one? Not exactly. The key lies in the rays, long streaks of debris radiating from the craters. For most impacts, rays spread in all directions like those from Tycho Crater, but here the rays are confined some stream north and south, while others extend westward only. The explanation: a cosmic body struck the moon at an incredibly shallow angle, less than 15 degrees above the horizon, and before it hit, it had already broken into 3 pieces. Each fragment carved its own crater, but all within moments of each other. One of these impacts flung ejecta directly onto the crater beside it, burying and aging it prematurely. What looks like an ancient scar is in reality the same age as its neighbours. If you picture a stone skipping across a pond, leaving splashes in its wake, you can imagine how Messier Crater was born. The result is one of the most unusual crater chains on the moon. Not all unusual craters are the result of shallow impacts. Sometimes it's the terrain itself that shapes the outcome. Consider a crater perched on what was once a towering lunar peak. In oblique images, shadows reveal that the crater formed right at the summit of a steep slope. A topographic map confirms it. The impact site may have been the highest point in the region before it was destroyed. Think about that for a moment. Imagine Earth's Everest, wiped away in an instant by a meteorite strike. On the moon, that's exactly what happened here. The asymmetric shape of the crater is partly due to the angle of impact, but also because the impactor slammed into a slope that dropped 8 kilometres over just 20 kilometres of distance. In other words, the landscape itself conspired with the meteor to produce something entirely unique. Even the tallest mountains in space are vulnerable. Now, let's travel to the moon's far north. In a wide, barren landscape, a single peak glows in sunlight, standing like an island in the dark. This is the rim of Messier Crater near the lunar North Pole, and peaks like this could hold the key to humanity's future on the moon. Why? Because hidden at the bottom of nearby craters, places the sun never reaches, lie deposits of water ice. For a future colony, ice means everything: drinking water, farming, even splitting it into oxygen for breathing and hydrogen for rocket fuel. But the poles also offer something else: sunlight. Unlike most places on the moon, where the day-night cycle lasts 28 Earth days, some polar peaks are illuminated almost continuously. A peak like the one here receives sunlight about 89% of the year, making it an ideal spot for solar power. Imagine future astronauts building their base here, solar panels stretched across the ridge, while below, rovers harvest ice from eternal shadows. From this lonely peak, humans could survive and even thrive on the moon. It's not perfect, of course. Even these peaks fall into darkness for brief periods. But compared to anywhere else on the lunar surface, they are prime real estate for the first outposts. Before we finish, let's glance at another hauntingly beautiful scene: the Bhabha crater on the moon's far side. In this 80-kilometre wide impact, basin central peaks rise like islands glowing in the sun, while the surrounding crater floor lies in shadow. These peaks formed when the impact rebounded the surface upward, a signature of what scientists call a complex crater. Scenes like this remind us of the dramatic violence that shaped the moons and the strange beauty that followed. So what have we seen? The moon may look familiar, but thanks to the Lunar Reconnaissance orbiter, we now know it hides landscapes far more diverse and puzzling than we imagined. Concentric craters that defy easy explanation. Landslides that show the moon is still quietly active. Low-angle impacts that carve craters like skipping stones. Mountains erased in an instant. Peaks at the poles that could one day power and sustain human colonies. The moon is not a dead world. It is a place of mysteries, puzzles, and possibilities. And as we continue to study it, we get closer not only to solving those mysteries, but also to stepping onto its surface again. Thank you for joining us on this journey. If you enjoyed exploring the moon with us, be sure to subscribe to Cosmic Compass for more stories from our solar system and beyond. Together, let's keep reaching for the stars. This has been Cosmic Compass, your guide through the universe. If you enjoyed this exploration of the moon, give the video a like, share it with fellow explorers, and subscribe so you don't miss our next journey into the cosmos. Until then, keep looking up. The universe always has more to show us.